Today, we are diving deep into one of the oldest, most crowded neighborhoods in our entire galaxy. We're on the case of a truly magnificent object, the globular cluster Messier 28. Just try to picture it, a dense, glittering city of stars, a real fossil from the dawn of the Milky Way.
But this isn't just another pretty picture from space. Oh no. Think of it more like a cosmic crime scene, one that's billions of years old. And for astronomers, the light coming from these stars, well, that's the evidence. They're the detectives, and it's their job to piece together the long and, as we'll see, possibly violent story of this incredible star cluster. And that brings us right to the heart of the mystery. Is Messier 28 just another beautiful ancient star cluster, one of many that are orbiting our galaxy? Or is it something more? Could it be the survivor of a truly dramatic past and maybe even a key clue to how our very own Milky Way was built? To solve this, we're going to follow the evidence step by step. First, we'll open the case file on M28. Then, we'll see how astronomers decode its light to get clean evidence. After that, we'll build a detailed profile of our suspect, follow its trail through the galaxy, and finally, we'll deliver a verdict on what this thing truly is.
All right, let's get this investigation started. Our suspect, Messier 28, lives in a really tough neighborhood, the Galactic Bulge. We're talking about the dense, chaotic, star-packed center of the Milky Way. And trust me, trying to investigate any single object in there is incredibly difficult. So we know M28 is ancient, and we know it's massive. But to really get its story, astronomers face this huge challenge. They've got to somehow isolate it from the millions, and I mean millions, of unrelated stars that are in front of it and behind it. It's kind of like trying to listen to one single conversation in the middle of a packed, roaring stadium.
So how on earth do they gather the evidence? Well, to crack this case, astronomers can't just take a simple snapshot. Nope, they need some seriously sophisticated forensic tools to filter out all that background noise and focus only on the light coming from Messier 28 itself. You see, when they first plot out all the data they collect, what they get is, well, it's a mess. It's just this chart of star brightness and color that is totally contaminated by all those other stars that just happen to be in our line of sight. It's like a photograph that's hopelessly crowded and way out of focus.
And here you can see the problem perfectly. The raw data, it's a total sea of stellar contamination. The actual pattern of the cluster stars, its unique fingerprint, is completely buried in there. It is absolutely impossible to draw any real conclusions from this.
So they had to clean it up, right? Researchers used this really powerful statistical algorithm to do something called decontamination. It's basically a forensic process that compares the stars in the direction of the cluster to a nearby control field of stars, and then it systematically subtracts all the ones that don't belong. It's genius.
And here's the result. I mean, wow, it's stunning, isn't it? With all that contamination stripped away, the true nature of Messier 28 just snaps right into focus. You can clearly see the cluster's distinct fingerprint, that main branch of stars, the turn-off point that tells us its age, and that stream of older, bloated red giants. Okay, now we have some clean evidence to work with.
With our evidence all nice and clean, it's time to build a proper profile on our ancient suspect. We're going to look at its age, its location, its chemical makeup, and its size to figure out exactly what we're dealing with here. First up, age. The analysis shows that Messier 28 is somewhere between 13 and 14 billion years old. Now, to put that into perspective, the universe itself is only about 13.8 billion years old. So this isn't just some old object. It is a direct relic from the era when our galaxy was just starting to form. Incredible. Next, where is it? Well, the data puts it at about 5 kiloparsecs from us. That's a massive astronomical measurement, and it's equal to over 16,300 light years from Earth. So yeah, it's far away, but it's still considered part of our galaxy's inner circle, deep inside that central bulge. Now for its composition. This is a key clue. The research found an incredibly tiny variation in the amount of iron among all its stars. Now, what that chemical purity tells us is that all the stars in Messier 28 were born from the exact same cloud of gas at roughly the same time. They're basically all siblings. There are no signs of different generations of stars here. And finally, its size. Make no mistake, M28 is an absolute heavyweight. Based on how its stars are moving, astronomers figure it has a mass that puts it in the top 30% of all known globular clusters in the Milky Way. So let's recap our suspect. It's ancient,
It's massive, and it's chemically pure.
Okay, so we've got a clear profile. The next phase of this investigation is to track its movements. By analyzing how Messier 28 actually moves through the galaxy, we can reconstruct how it interacts with its environment. And that is where the story gets really interesting.
Check out this chart. It's tracking the movement of stars in the region. You see that tight little clump right in the center? That's the cluster, all moving together as one cohesive group. This data lets astronomers calculate its orbit, and it reveals that M28 is literally trapped on this tight, looping path, confined entirely to the galaxy's central bulge. And here it is. This is the smoking gun. That tight orbit, it comes at a cost. The immense gravity of the Milky Way's core creates what are called tidal forces, which are constantly stretching and pulling on M28. The research paper confirms it. The cluster is actively losing stars because of this. It's being slowly torn apart, leaving a trail of its former members behind like cosmic breadcrumbs.
Okay, it's time. Time to review all the evidence and deliver our verdict. We've gathered the clues, we've profiled the suspect, and we have tracked its movements. Let's put all of the pieces together to finally reveal the true identity of Messier 28.
So, here's what we know for sure. It's unbelievably ancient, born at the very dawn of the galaxy. It's one of the most massive clusters of its kind, yet it's chemically very simple. Its orbit keeps it trapped in the galactic core, where it is being actively ripped apart by gravity.
So what does all of this mean? Well, the evidence points to one pretty stunning conclusion. Messier 28 isn't just another globular cluster. It is the surviving core of a much, much larger structure from the galaxy's infancy. It's what astronomers call a primeval building block, a dense remnant of one of the original objects that merged together to form the Milky Way. And this leaves us with one last tantalizing thought. Given its huge mass and its violent history of being stripped apart, could we be looking at the fossilized heart of a small galaxy that was completely swallowed by our own billions of years ago? Messier 28 might not just be a witness to the Milky Way's formation. It may be one of its fundamental components, a survivor telling a breathtaking tale of cosmic cannibalism and galactic construction.